Thank you very much, Dragon, and thank you very much to the organisers for this opportunity to come and speak to you. Given some of the earlier comments about sustainability and the mining industry, as the only equipment supplier here, I feel a little bit vulnerable, but I hope that what I'm going to talk about will perhaps begin to change some attitudes towards the way the equipment suppliers in this industry are trying to develop new and innovative techniques to make our industry more sustainable. So I will start with a short introduction to FLSmidth for those of you who are not familiar with us. We are a global leading supplier of equipment to the mining, minerals and cement industries. We supply everything from single pieces of equipment through to complete cement and minerals flow sheets. Our core minerals businesses are copper, gold, coal, iron ore and fertilizers. Though with a very broad product portfolio, there are very few aspects of minerals processing that we are not involved in. We're a Danish company. We are listed on the stock exchange in Copenhagen, and at the moment we employ somewhere in the region of 15,000 people. We are a truly global organisation. We have subsidiaries and offices in 50 different countries worldwide, and we add to that on a regular basis and modify our footprint depending on the needs of our clients and how we can best serve them. This is a market we are particularly interested in the next 5 or 10 years, and I dare say there will be an FLSmidth Serbia before too long. FLSmidth works in many different areas of research and development, but given the time and the theme of the conference of sustainability, I've only focused on one particular subject that we are working on, which is the work we're doing on water recovery and tailings disposal. Water is a big issue in the mining industry. It's not the same issue everywhere. There are certain countries who have massive shortages of water, and you think automatically of Saudi Arabia, you think of Iran. There are parts of Kazakhstan which are huge deserts. The Atacama, where people are now told that they cannot extract but must desalinate and pump water from the Pacific 4,000 meters to their copper plants. This adds incredible cost. Mineral processing in the form that we currently have, and I accept the point earlier that nothing much has changed in 100 years. We're very good at making things bigger, but we've not really changed. We can consume enormous amounts of water. If we're talking about a major copper concentrator, you could be looking at a consumption of 50 to 70 million litres of water a day, some of which is recovered, some is recycled, a lot is lost. Water, as I mentioned, is a globally scarce resource, and mining in dry areas places very high levels of stress on the available water resources, which can result in conflict with local residents who have their own needs. However, we firmly believe it is possible to do more. There are also other reasons to try to recover and conserve more water from the tailings that we throw away. And this is to do with the way we currently discharge our mine waste. Historically, I think it's fair to say mine waste and mine closure was very much an afterthought to the extraction of the value mineral and maximising the mine's production. FLSmidth, through one of our previous companies, pioneered the use of specialist thickeners for the dewatering of tailings, which are now allowed new water-free tailings disposal schemes to be implemented in the late 90s and 2000s. In fact, again, picking up on the early point about how long it takes the mining industry to react, between 1996 and 2006, we changed the tailings disposal system on over 100 mine sites, which for the mining industry is quite a rapid rate of acceptance. Thickened tailings disposal, and paste, as you will hear it called, is now accepted as the new normal for the disposing of mine waste. There is, however, still room for improvement, and we continue to pioneer new and innovative ideas for the handling of tailings and the other waste streams that come from the mine. There are several benefits to improving the way we treat and handle our mine waste. A better waste system can have a smaller footprint. You need less land, which is a cost. You leave less behind, which is your legacy. Increased water use. And in particular, where there is a real limitation on available water, the more that you can recycle, the more your mine can produce. And this can be critical, and is critical in places like Chile and Peru. Closure costs around tailings dams can be phased through the mine life rather than incurred only at the end of production, and this minimises impact on the balance sheet. It also shows a responsibility of the ownership to be able to address the environmental concerns of the legacy of the mine during the operating phase. Minimising the impact of our mines helps to support a social licence to operate. Not only do we need to compete for investment opportunities and compete for finance, we need to present ourselves in a way that people will permit us to do our job. And finally, there is a significant reduction in risk. Tailings dams fail. Samarco, BHP and Vale, not a company that you would expect to have a tailings dam failure, a company who pride themselves on the environmental work they do. There are 2 failures per year on average, and there has been for the last 30 years. There have been 21 serious failures in that time. So despite our best efforts, we are not getting better. So, dry stacking, dry disposal of tailings. This isn't new. Little in the mining industry really is new. It's always been done before somewhere else. The UK coal industry filtered their tailings for many, many years, particularly on the back of several disasters in the UK. La Copia, the project in Chile, which unfortunately finished its mine life last year and is no longer operating, filtered and stacked their tailings from their copper operation throughout the mine life. However, these are relatively small operations, and large dry stack tailings operations present new, bigger challenges. In particular, we needed to develop equipment to be able to treat very large tonnages of tailings, which are fine and difficult to dewater. So to do this, we upscaled our biggest filter press and developed a machine which is 2 meters by 4 meters, twice the size we previously had, which would be capable of treating between 10,000 and 20,000 tons per day per machine, depending on what you're treating. This filter was recently put into operation in Chile on a demonstration plant. There is a downside to filtered tailings. In order to make filtered tailings geotechnically competent for disposal, it does need to be quite dry. That leads to long cycle times in the equipment and can lead to a large number of filters as a result, a very high capex and a very high opex. So, one of the benefits of FL Schmidt is that we have a very wide range of equipment in our product portfolio, and we were able to talk to our cousins and brothers and sisters across our organisation about what else could be done with tailings other than just filtering. And we are lucky enough to have the thickeners, the filters, and the materials handling systems to be able to take this filter cake and dispose of it in quite unique ways. So rather than just filtering, if we know and accept that tailings dams fail and we would like to move away from them, we know that they present a liability to the industry we would like to get rid of, and water we accept is expensive and scarce, we need a bit of a change to the way that we handle our tailings and the way we go forward. And this is what we refer to as eco-tailings. This is a project we're working on in collaboration with Goldcorp, and we have some, the benefit of working with a mining company on this is we have some very strict financial targets in terms of OPEX and CAPEX, which we have to meet because they do not want to see this increase their operating costs. In simple terms, we were given a project size of 100,000 tonnes per day, and we were told their CAPEX and OPEX for the tailings and the mine waste would be $2.50 per tonne of placed material, and that was our target. So, what do we mean by eco-tailings? Well, it's a mixture. It's a mixture of the filter cake and the waste rock from the mine. So if we can mix these two together sufficiently well, we can create a new material which can be disposed of without the tailings dam and also without the downside of waste rock dumps, of which there are a few. We need to do the blending with the minimum and ideally no yellow plant. So this is all done in the conveying process and spreading process out to the tailings stack. And these were some of the challenges that we faced in doing that. We knew that to filter these tonnages of material, we would use our previous filter. I think we decided we would need 72, which was not going to happen. If we came up with our new big filter, we would still need 36, and realistically, that wasn't going to happen either. By blending the filter tailings in with the dry waste rock, we are able to accept a higher moisture filter cake. So we're treating the tailings and the waste rock holistically, so together, and we're able then to run the filters in a completely different way. We're not chasing the driest possible filter cake. And now the number of filters went from 72 down to 8, which is more acceptable. Obviously, lower would be even better. We're targeting a cake which is somewhere between 18 and 20%, and the balance of this obviously is then mixed away in with the dry waste rock. How does it work? The tailings occupy the spaces, as long as you mix it properly, occupy the spaces between the coarse rock. The filter cake is broken up. This removes or significantly reduces the air gaps within the dump. It also reduces the permeability. Waste rock dumps are permeable. When it rains on a waste rock dump, the rainwater passes through, there is oxygen and air present, sulfide minerals acidify, and you get acid runoff from the bottom of the dump. If we can reduce the permeability, prevent the flow of water, and occupy the air spaces, we can prevent or significantly minimize this happening. The coarse rock brings added stability to the fine tailings material. So in the past, where we were worried about the fine tailings and the ability to travel on them, or the stacking, or the reliquefaction in the event of an earthquake, the coarse rock helps to bind it all together. And as I mentioned before, the key here is to do this in the transport system rather than do it on the stack itself. So if we take the two problems in isolation, tailings, typically saturated, typically water on the dam, low shear strength, the risk of dam failure, physical stability issues of the dam walls, low permeability and anaerobic. And on the other side, we have our waste rock, where we have typically unsaturated material, high shear strength, great stability, you make a very steep stack with waste rock, high permeability, a downside, and aerobic, which is also a downside. But combining these two together, we can actually win on both counts and lose the worst properties from either side of the equation. So just to give you an idea, and a very outline idea of the typical water balance, most of the water work recovery is still done at the thickener, which is at the beginning of the process. About 2/3 of the water is recovered, the rest coming from the filter plant. There will be a small amount of runoff which is collected back from the dump, stormwater, etc. So, were we able to meet the challenges? This is an ongoing project, I hasten to add. The conventional wet tailings facility, the tailings OPEX is about $1.05, and the tailings rock fill was about $1, which gave us our $2.50 target. we are running at an OPEX of less than $2, and we've got the CAPEX to about 50 cents. So we are there or thereabouts. We're matching what they currently spend. We have achieved a significantly higher water return, as you would expect, and geotechnically, the material that we are placing is very stable and does not present a risk of collapse. Pretty picture of what the scheme might look like. This is an open pit technology. You would typically not have enough waste rock in an underground mine to be able to do this. So you're looking for, there will be a window of strip ratios within which you will operate. If you, a small note about stacking on these radial stackers at the end. If you only stack tailings, the filtered tailings, you can only lift about every 2 meters. Whereas if you go with the waste rock, because of the stability, you can make a much, much higher lift at each pass, which is a big saving as well. So really, in conclusion, despite, and I think it's a very fair criticism, there are things going on in the mining industry. People are trying to push boundaries and find new and more sustainable ways of doing things. We've done a lot of work in the past with filtered tailings, with paste tailings, and with thickened tailings, and we're now taking that forward to see what can be done with that material and with waste rock dumps to provide a holistic life of mine approach to a low-cost solution which won't give you the liabilities of during the mine of your tailings. Thank you very much.
Thank you.